Hello viewers, welcome to this session. In this session we will be talking about the camera and its controls. This is the first session. Here we will be talking about the camera. You know there are different kinds of camera. We will follow one kind only, but in general whatever the camera you see, they have some common features. We will be talking about the common features, that is the essential parts. These comprise of the camera body, a lens and the viewfinder. Then we will be talking about the camera controls. In camera controls we have two different parts. One is the lens control, where we control the focus, we control the aperture and we control the zoom, and the other one is the exposure control, that is governed by the shutter. Camera is the significant tools used for generating visuals. There are other devices that also generates visuals, but there are not many. For example, there is a computer with which you can generate visuals. Other than that, a painter can generate a visual, so you can draw a picture. Now a camera is a device that captures optical image on a photosensitive material with the help of light. Now I will be talking about the lens. Lens is an optical device made of transparent material bounded by two sides, one of which must be a part of a sphere. Now you know there are different kinds of lenses there, like biconvex, plano-convex, convexo-concave, meniscus, plano-concave or biconcave. Now every lens has a focal length. The focal length is the distance from the center to the principal focus of the lens. Now what is the principal focus? I will discuss that. The light travels from a far away object parallel to the principal axis of the lens. After refraction, it converges into a point on the principal axis, and this point of convergence is known as the principal focus. I have said already the distance from the center of the lens to the principal focus is the focal length of the lens. Now a camera lens has to be essentially a positive lens, and a positive lens only forms a real inverted image when the distance of the object is more than one focal length of the lens. Now different lenses of different focal length can produce remarkably different pictures. For example, here we have four pictures. One is of focal length 28 millimeter, the other is 35 millimeter, the other is 50 millimeter and 70 millimeter. Here you could see the field of view is different from each and the other. A 28 millimeter lens is covering a bigger angle of view. A 35 millimeter is covering less than what is covering by 28 millimeter. 50 millimeter lens is covering much less, and a 70 millimeter lens is covering further less. So when we are talking about the field of view, we in photography we normally consider the horizontal field of view, because when you see a lens, it covers both horizontally and vertically. Mostly when you talk about the field of view of a photographic lens, we talk about its horizontal field of view, and accordingly we have classified these lenses into three groups: normal, telephoto and wide angle. Now we have lenses having fixed focal length, and these lenses are called the prime lenses. I have talked to you regarding different types of lenses: normal, wide and telephoto. But you know, it is not essential that you have to use different kinds of lenses. There is one very famous photographer, Henri Cartier-Bresson. He used throughout his life only normal lens. His concept was that he said that the way I look at it, in artistic way that I look at the object, I want to convey the same impression to my viewers. So, he never used any lens which is more than a normal lens. He said a lens is an extension of my eye. So, he never used any lens other than a normal lens. But it is not true that you do not need any other lenses. You can use other lenses, but you must know what is the effect of that lens on the screen. The another essential parts of the camera is the viewfinder. When we take the picture through a camera, the image forms inside the lighted chamber, and from outside, to get an idea that how much area the lens is covering or what type of image is forming inside, we use viewfinder. Now, there are different kinds of viewfinder available. The most primitive viewfinder is a ground glass viewfinder. You must have seen the early photographers, they used to cover themselves with a black cloth and they go inside and looks at the ground glass. Actually, the image forms on a ground glass. By looking at the ground glass, they used to find out, they used to focus the image, they used to adjust the camera and do their corrections, and then finally they used to put a plate and record on that. So, that is a ground glass viewfinder. Next is the optical viewfinder. Now, this type of optical viewfinder you get nowadays in most of the cameras, especially non-professional cameras. They have a lens for taking the picture and there is a window for viewing the image what the camera is covering. When you look through the viewfinder from the back of the camera, what you see is different than actually what the camera is seeing. So, this type of optical viewfinder is essentially not very perfect. So, no professional camera has this sort of viewfinder, because there is a error, what we call a parallax error, that occurs when subject is very close to the camera, but when the subject is far away, they do not have a problem. You know, sometimes when we take pictures with optical viewfinder, sometimes we have seen the head gets chopped or the leg gets chopped, or you have not exactly taken the picture what you have seen. So, this is a problem with optical viewfinder. They put two lenses identical, one for taking the picture, the other for viewing, and there is a 45-degree mirror which reflects the light which is coming from the lens and falling onto a ground glass, and we look at the image from the top and find out what is the image. Again, twin lens reflex cameras or the twin lens reflex viewfinder system is not ideal. Again, there is a distance between the taking lens and the viewing lens. Since they are not in the same plane, since there is a distance, the images again have a problem of parallax, especially when the object is close to the camera. This problem is solved by single lens reflex viewfinder, where we are using a single lens for taking the picture as well as for viewing. This is being used in most of the professional cameras. Here you can see the light path enters in through the lens and then it gets reflected by a 45-degree mirror and it reflects to it and it falls onto a ground glass. And on the top of the ground glass there is a pentaprism arrangement. With the pentaprism arrangement, the light gets reflected twice and then it goes in the horizontal axis, and from where through the eyepiece a person can see what the image is forming inside the camera. And at the time of taking, the mirror swings up and the light directly gets into the negative or the film, and it records the image. Now, in the digital cameras, we get the LCD screens. They are a output what the camera is recording, an output which is given to the LCD screens, and we get the idea what the camera is covering. So, there are different types of viewfinders we use for different types of cameras. Now, I will be talking about the camera controls. That is, there are two types of camera controls which I have already explained. One is the lens control, other is the exposure control. In the lens, the outer ring of the lens is the focusing ring, and this focusing ring adjusts the, or by turning the focusing ring, we make the image sharp on to the camera. How we do? In optics, focusing is governed by a formula which is very famous formula known as 1 by u plus 1 by v is equal to 1 by f. Now, in v is the object distance, u is the image distance, and f is the focal length of the lens. So, when we focus certain object, we do not change the focal length. What we do? We adjust the object distance and image distance when the focal length of the lens is fixed. So, if the focal length of the lens is fixed, when we move the focusing ring, actually we adjust the distance between the object to the camera lens. And when we do that, we also simultaneously adjust the image distance, and this is governed by a famous lens formula known as 1 by u plus 1 by v is equal to 1 by f. We know for our case f is constant. So, when we change u, that is the object distance, we change the image distance. By varying these two, we get into a situation where it satisfies the equation 1 by v plus 1 by u is equal to 1 by f. Now, you have to adjust the object distance and image distance to get the image sharp on the focal plane, that is on the film. Next is the zoom control ring, which is the ring you have next to the focusing ring on a lens barrel. Now, you know the zoom control ring, it is a ring by turning which you can change the focal length of the lens. Now, first of all, we have to understand what is a zoom lens. A zoom lens is a variable focal length lens where you can vary the focal length of the lens by turning a ring. There is an advantage of it because with a single lens you can get a variation from normal, wide and tele. Okay. So, by turning this ring you can go for any focal length. There is a permissible focal length on which this lens is offering you. For example, you can get a focal length from 10 to 100 millimeter. So, the power of this zoom lens is known as 10x. So, it can give you image up to 10 times magnification. What you get at 10 millimeter the image size, and what you are getting the image size at 100 millimeter, the image will be 10 times magnified, and you can get a lens from 35 millimeter to 110 millimeter. So, here you can get a lens of wide angle, normal and telephoto. So, when you describe a lens, when you describe a zoom lens, we normally tell that it has a range of focal length, and all the time on the lens itself it is marked that its focal length range, and at the same time it is also marked its magnification power, which is expressed in terms of x. For example, a lens of 25 millimeter to 250 millimeter has a focal length 25 to 250 millimeter and 10x. That means it can give you a magnification up to 10 times when it is at the maximum range of the focal length, and when it is at the minimum focal length, it is 10 times less than the maximum. The aperture and the shutters are the two controls which controls the exposure. Exposure means the amount of light that is allowed to fall on the photosensitive material to form the image, and this is expressed in E, and there is a formula called E is equal to R into T. R is for intensity of the light and T for the time duration through which the light is allowed to fall on the photosensitive material. I have expressed that the intensity of the light is controlled with the help of an aperture. Now, what is an aperture? Aperture or the diaphragm is made of metal blades overlapped, and when they are sprayed, it opens totally, and when you close them, they close with a small opening. Now, the opening of the lens can be controlled by controlling the aperture ring. You can open it wide or you can make it a very small hole. Now, we express this aperture with a number, and this number is expressed in terms of f number, which is otherwise said is a relative aperture. Relative aperture is a ratio between the focal length and the actual opening of the lens. If you look at the aperture ring of any camera, you will find there are certain numbers is printed on the ring. They are numbers like 1.4, 2, 2.8, 4, 5.6, 8, 11, 16, 22, 32. Now, these numbers, when you look at these numbers, now these numbers 1.4 to 32, the more the number, less the opening. The lesser the number, more the opening. For that means at 1.4 the lens opening may be full, or at 22 or 32 the lens opening is minimum. The smaller the f number or the stop, greater the lens opening, and the greater the f number, smaller the lens opening. Now, it is, you can see that at 1.4 here from the diagram you can see the lens is opening fully, at 2 it is much less, at 5.6 is much lesser, and at 22 it is the smallest. There is a relation between these numbers. From 1.4 when you are moving to 2, you are cutting the light by half. When you are moving from 2 to 2.8, again you are cutting the light further half. So, from 1.4 to 2.8, the light is reducing by 4 parts, or we call it in 2 stops. The light cuts by 4 times. The other way around, if you open from 5.6 to 4, again you are allowing the more light, double the light to pass through the lens. So, with the help of aperture, we control the amount of light that is passing through the lens and falling onto the sensitive material. And to control that, we have a guidance that we do it with the help of aperture, and from the outset we can find out from the aperture ring with their respective f numbers. I have explained already, the f number is the ratio between the focal length and actual opening of the lens, which we again called it relative aperture. To control exposure, we have another device which is mostly situated in the camera body, is known as shutter. Shutter is a spring activated mechanism that allows the light to pass through the lens for a precise duration. Now, how does a shutter function? The first of all, the shutter protect the unexposed material being exposed through to the light. So, it is first is the shutter is covering the unexposed material. It does not allow the light to fall on the unexposed material. when operates, it opens for a small duration and allows the light to pass through, and thereafter it protects the exposed material from further exposure. Shutter has three functions mainly. First of all, it protects the unexposed material or the unexposed photosensitive material, that is film, from exposure. When we operate the shutter or when we click the camera, the shutter opens for a brief period and allows the light to pass through, and it exposes the film. After the exposure is over, the shutter gets closed, and now its function is to protect the exposed film from further exposure. Now we have different shutter speed that can be controlled by the shutter speed control on the mostly situated on the top of the camera body. There you can see there are numbers like 1, 2, 4, 8, 15, 30, 60, 125, 250, 500, 1000, 2000. Now what this number indicates? This number indicates the shutter speed is 1 by that number. That is, for example, if it is 1 by 1, it is 1 second. 1 by 2 is equal to half a second. 1 by 30 is a 30 part of a second. 1 by 125 is 1/25th part of a second, and at 1 by 1000 it is 1 by 1000 part of a second. Because of this, we call camera is a precision equipment, because it can operate for precisely exact duration, for example, as close as to 1 by 1000 or 2000 part of a second. Now, other than these numbers, you get two letters, one is T, another is B. The B stands for brief time. So, when you press the shutter release button, until you release, it will remain open, and the moment you leave your hand, then it will close. So, it is for a brief time you can keep the shutter. This is used mostly for giving longer exposures. Then other one is T, is a time exposure. There, the moment you click once, it gets open, and further until you click it again, it remains open, but the next time you click again, it gets closed. So, we have to control the exposure, we have two devices in the camera. One is situated in the lens, that is the aperture. The other one is situated on the camera body, that is the shutter. Now, by combining these two, you can control the exposure. I have already explained E is equal to I into T. E is the exposure, I is the intensity which is controlled by the aperture, and T is the shutter speed. And to control the aperture, you have different aperture numbers, f numbers, and to control the shutter, you have different shutter speed. When we expose a picture, we expose with the combination of aperture and shutter. For example, you can expose a scene, normal daylight, with an aperture, for example, f11 and shutter speed 1 by 1/25th part of a second with a film of 100 ISO. Now, the same exposure can be made by changing or a different combinations of the aperture and shutter. For example, the examples I have given just now, that can be exposed instead of 1 by 1/25th part of a second at 1 by 60th part of a second, and that means you are allowing more duration of light to pass. That can be counteracted with the aperture of f, instead of f11, now you can go for f16. So, what I have done? I have increased the aperture, or I have closed the aperture by one stop, but open the shutter speed by one stop. So, this is a counteracting device. So, in a camera, essentially you need to have a light tight chamber, okay. Then you need a lens, you need a viewfinder, and to control the camera, you have aperture and shutter. So, these are the basic controls with which we take pictures.